Welcome to Domain 2. Although Domain 1 is seemingly the most important domain based on the rankings, Domain 2, which is telecommunication and network security, is actually a bigger domain, and a lot of the other domains will have an interleave to this. So this is, as far as I'm concerned, one of the most important domains to get under your belt, and it may seem quite daunting. Now, what the IC² candidate information bulletin tells us is that the telecommunication and network security domain encompasses the structures, the techniques, the transport protocols, and security measures used to provide integrity, availability, confidentiality, and authentication for transmissions over private and public communication networks. The candidate is expected to demonstrate an understanding of communications and network security as it relates to data communication in local area and wide area networks, remote access, internet, intranet, extranet configurations. The candidate should be knowledgeable in networks equipment such as switches, bridges, and routers, as well as networking protocols, for example, TCP/IP, IPsec, and virtual private networks, VPNs. Before I go to the next slide, IPsec is really important. You need to understand that fully. We'll hit that later, but it's important for yourself to maybe look at a Windows environment and try and install it yourself and see how it works. Now, we're going to look at a couple of the basic foundations. We're going to look at the OSI layer, the TCP/IP models, ports and protocols, network devices, security controls and countermeasures, virtual private networks, network access servers, and then finally cloud computing. Now, when we start, basically, we need to understand that we're going to look at some network security issues. We have to understand that there are network structures such as networking configurations. There's transmission methods such as cables and photons, meaning light, transport formats, and security measures around those. Network security is the cornerstone for business operation. We need to understand that our network security, when we go to a client and we consult a client, it has to be business driven, where technology is the enabler. Now, when we look at the network models, the two most important models is one, the OSI reference model, which is 7 layers, where the 3 top layers is not distinguished in the internet model, which is the next model, which is the TCP/IP model, and that's 4 layers. The next 3 models I've just identified here, such as the ARPANET reference models, and it has 3 layers, Starlings and Tannenbaum, which both have 5 layers. We won't focus on that, but you need to understand that there are other models in the design. However, the focus is on the OSI 7 layers and how the TCP/IP model 4 layers relate to that. The OSI reference model consists of 7 layers. We have layer 1 to layer 7, layer 1 being the physical layer, the device in your machine, then the data link layer, the network layer, the transport layer at layer 4, session layer at layer 5, presentation layer, and finally at layer 7, the application layer. I usually give people a donkey bridge to remember this, and if I go from layer 7 to layer 1, all you have to remember is that all people seem to need data protection, and this is the sequence of the layers. When we look at the OSI layer with the TCP/IP layer, you can see on the top the application, presentation, and session layer of the OSI model is all combined as a single layer in the TCP/IP model. This has been done by the Data Defense Department in America to make the implementation easier. Then basically we have transport, which is host-to-host in the TCP/IP model, network, which is internet in the TCP/IP model, and then finally the data link and the physical layer has been combined to define the network access layer. Now, encapsulation or layering is a method of designing modular communication protocols in which logically separate functions in the network are abstracted from their underlying structures by inclusion or information hiding within higher level objects. Data information bytes are used to determine action on these packets. To make it more simpler, as you can see from the application, when I communicate, now the application from my side, if I want to send, for example, a packet, which is part of the mail, to another system, every layer from my side and the application side that goes right through to the physical side, encapsulation or the padding of additional data bits will be done to the data to inform the next layer what to do. So when it actually goes right to the physical layer, it will be padded with everything, goes across the wire, and then on the other side where it is supposed to be delivered, we'll strip those packets off to make sure that it actually knows what to do. This is another example, a little bit more in detail, where you can see encapsulation, padding or layering is that information is padded from the application layer right up to the physical layer, and then the information is stripped and information is used to control flow. Now, at layer 1, let's quickly go through it, and not in detail, but just to see what happens at these layers. So at the physical layer, bits are converted into signals, data transmissions and reception happens there. All signal processing happens at the physical layer, such as character encoding, transmission, reception, and decoding. And then physical topologies are defined, which we'll see a little bit in detail. Definition of hardware specifications, interfaces with the data links, media access control or MAC sub-layer. At layer 2, which is the data link layer, this layer connects layer 1 and 3. This layer also has 2 sub-layers, which is the logical link control sub-layer, LLC, which does the error and flow control. And then we have the media access control sub-layer, or the MAC, or the MAC. This is where VLAN, quality of service, switching, and physical addressing takes place. Encapsulation of network layer data packets into frames. We have frame synchronizations at the data link layer, and also where it transmits frames to devices. And as an exception compared to the rule at the layers, link layer encryption takes place at the data link layer. At layer 3, which is the network layer, this moves information between 2 hosts that are not physically connected, such as packet forwarding and routing. It uses logical addressing. There's the Internet Protocol, there's IP version 4 and version 6, and then also message forwarding takes place at the network layer, where IP version 6 has a better design for mobile follow-me control flow. At layer 4, which is a transport layer, it has end-to-end transport between peer hosts. It is defined in an RFC 1122. This is the TCP/IP model. It has connection-orientated and connectionless protocols. We have byte orientation, where we have same order delivery. There's some reliability control. There's flow control, congestion avoidance, and then also multiplexing, where ports can provide multiple endpoints on a single node. At layer 5, which is the session layer, this manages logical persistent connection, authentication, authorization, and session restoration. Checkpointing and recovery takes place here. There are 3 modes, such as full duplex, half duplex, and simplex, where full duplex, both directions at the same time. This is the communication flow. Half duplex, it flows both directions, but only one direction at a time. And then simplex, where communication that occurs into one direction only. So we have a sender and a receiver. At the presentation layer, this is where it ensures a common format to data, such as data conversion. We have character code translation, and also services for encryption and decryption, compression and decompression. What I usually say is, to remember this, you need to look at a computer and you want to look at an image or a video on your computer screen. It has to present it to you as the end user. And this is why I say this is where we have compression and decompression taking place, such as MPEG for movies, bitmap and GIF and JPEG for images, and it presents it to you. So this is and decompression. And finally, at the OSI model layer 7, which is the application layer, this is an abstraction layer. And you need to understand this is not the applications, but it's called an application layer, where it performs communication between peer application. This is the area also the least control of network security. The application layer protocols use the underlying transport layer protocol to establish host-to-host communication. Basically, this is a slide that actually just shows us the layers and the functionality of these layers. So I think it's important to go through that to look at the data units, the layers, and the function of each layers as a quick review. Now, the TCP/IP model, in relation to the OSI model, this originated by the U.S. Department of Defense, also known as the DoD model. It functions like the OSI model. However, the link layer contains communication technologies for a single network segment, such as a link of a local area network. The internet layer, the IP, connects independent networks, thus establishing internetworking. The transport layer handles host-to-host communication. The application layer contains all the protocols for specific data communication services on a process-to-process level. For example, the Hypertext Transfer Protocol, HTTP, specifies the web browser communication protocol with a web server. It supports fully the TCP/IP protocol, and as said earlier, the application layer is unique. And once again, that is a TCP/IP model representation. Understand and actually look at this and see the layers orientation. Some data network structures, some acronyms to actually go through. For example, the local area network, also the LAN, is primarily limited to a small geographical area or a single site. That's an office or a building. A personal area network, or PAN, is data communication on network for short distance, such as Bluetooth or infrared. We have a wide area network, a WAN, which data communication networks to multiple long-range geographical areas. Metropolitan area network, a MAN, is a data communication network for a large city. Example, Washington Metropolitan, New York, or Boston. A campus area network is a data communication network for campus of buildings, such as a college campus or military base. Internet is a worldwide system of interconnected networks. Intranet is a type of network that serves as internal clients, such as users of a diverse range of telecommunication networks. And the extranet is a type of network that services to external clients, such as customers, over a diverse range of telecommunication networks. Now, when we look at network-based attacks, a network can act as a channel for attacks, which allows us to access confidential data unauthorized, also elevating privileges for unauthorized users. A network can be a target of an attack, such as a distributed denial of service, a DDoS, and SNMP community strings, very good examples, such as has the ability to have information leakage. And when we actually bypass that and hack any SNMP device, we can control and modify devices without authorization. Now, a control around this can include intrusion prevention systems and intrusion detection systems. Also, honeypots. Honeypots are devices or networks set up to act as an actual valid network, however, will have code to trace people and see what they're doing, and this can be used as evidence. In some states, honeypots are illegal, as this is seen as entrapment. Now, a network as a bastion of defense. So if you look at a bastion, it means that security controls are built around a social, organizational procedure and technical activities. It is based on the organization's security policy. And then Marcus Ranum, who's the developer and the author of the Old Firewall Toolkit, as well as Network Flight Recorder, says that a system is identified by the firewall administrator as a critical strong point in the network security. Generally, bastion hosts will have some degree of extra attention paid to their security and may undergo regular audits and may have modified software. Now, when we actually look at network security objectives and attacks, a business risk versus security solutions is a fine line, and we need to make sure that we act as the enabler for the business and do not lock it down too much. Some attack scenarios could be, for example, a network entry point in both directions. Often from the outside inwards is ingress, and from the inside out egress. Now, often firewalls will stop the first ingress but not egress. So examples such as go to my PC and log me in are applications where a user can control a computer from the outside to the inside, but however setting up the session from the inside out, thus bypassing the security rules in the organization. This is a very good example of the HoneyNet project, and this is alive, and there's quite a few on the internet, which monitor attacks worldwide. Now here, what you can see, there's some red dots here, and that is the source of the attack, and if the yellow indicates the destination. Now I've run this only for a few seconds, and as you can see, quite activity. Now what we can do is a methodology of an attack. We can actually identify and define attack trees, how we approach the environment, and then once we've identified my attack tree, I will go and access my path of least resistance. And this could include anything like access control error, authentication errors, boundary errors, the configuration of the network, an actual configuration error such as a default user ID and password in a router or a switch, exception handling error, too much information is given to the user, input validation error such as SQL injection, randomization error, and we've seen the Java toolkit recently on the Android device not creating randomization adequately, and some Bitcoin money was stolen because it can be predicted. And then also a resource error. Now, once any of these errors can be exploited, we need to identify if the user has got administrative rights. And once you've got privileged or elevated rights, we can use those rights to compromise the system. So the objective here is to make sure that we review the access rights of all users regularly and make sure they only use these accounts for the benefit of administration if it is a privilege level. Now, a target acquisition can include by intelligence gathering. Now, the numerous ways that can be done, for example, network scanning or social engineering, and countermeasures may include things like limit information on network, so it is not a noisy or a verbally active network, and we can also distract an attacker using honeypots or otherwise known as mousetraps. Now, once we've identified a target for security weaknesses, we can look at things like vendor notifications. If we know they've got Microsoft Exchange version 5.5 without patches, we know we can do a blue screen of death on a remote server using Telnet to port 25 with certain object-created code. Now, then tools available to go through a target analysis. There are commercial and open source tools, each depending on your usage, and using those tools. And I have identified in one of the slides a site that you go to, and I highly recommend it, called toptools.org, which identifies all commercial, open source and public domain tools in the security sphere. Once we use those tools, we can do footprinting and also port analysis. Port analysis, one of the best scanners, which is open source, is Nmap. Then once we've actually gone to a system, we need to obtain access to the system. This is the objective of a hacker. So privileged access needs to be created. Once he obtains that, he can create a backdoor and also escalate own privileges. Now, what you can do to contain this and to monitor this is to monitor all accesses and also possible to determine all privileged users. So if we have any delta change in administrative users or users, you need to actually make sure that there has been a form filled in or change control taken place. Now, once we've actually obtained the target, escalate our privileges. An attacker may seek to have sustained control of the system, and countermeasures against privilege escalation is monitor user access right, changes in any user, and also delta in the administrative users. Very important. Now, network security tools is to automate the processes. Skills are required to interpret the tools. A certain CIO of organization had a saying to me one day, which I found brilliant. He said to me, "A fool with a tool is still a fool," which means as long as you can use the tool, but you have to have the technical knowledge in the back end to interpret that data. Because port 1, 2, 3, 4, 5 on a TCP environment may indicate NetBus as a Trojan application distributed in an organization, or it may have Trend PC as an antivirus tool, both having the same port. Now, network security is more than just technical implementation. We need to look at all security policies. Then this is the link. There's the top 125 network security tools highly recommend to go through that and see the tools actually. Then also from those tools, you have certain scanners. You can have a discovery scanning such as ARP Watch, which is Address Resolution Protocol Watch, to look at all new machines. We can have a ping sweep to see which machines are up and running. SNMP sweep, which identifies where SNMP is installed and identifies certain attributes of machines. And then also DNS queries to determine which machines have woken up the DNS server to obtain an address. Compliance scanning, this will scan for things like patches applied, hotfixes, and service packs. And then finally, vulnerability scanning, which identifies the vulnerabilities in a system that has to be closed. Nessus is a tool, also Qualys, and many more that you can review. Now, the next step is actually a little bit more difficult because we're going into each layer and look at a little bit more detail of those layers, what happens at those layers. Now, from the layer 1 physical layer, there are communications technologies that we look at initially first. So in the technology, we have analog and digital communications, where analog communication is a method of internetworking utilizing analog signals through a combination of single amplitude, frequency, and phase. So voice, fax, modem, analog, and so on. Now, when you actually look at analog communication, and as it goes over a long distance and it actually weakens, that's called attenuation of a signal. Digital communication is a method of internetworking or utilizing digital signals through binaries of ones and zeros. Digital communication, the advantage is that it brings quantitative and qualitative enhancements. Now, when we look at analog communications, it is analog signals that use electronic properties. It is transmitted on wires or with wireless devices. And as you can see here, the blue line is the analog signal and the dots on the red lines are actual digital samples of that link. Digital communications uses two electronic states, ones and zeros. It can be transmitted over most media. Integrity of digital communications is less difficult. And also the next area, the physical layer, we look at the network topology. Now, the network topology means that how we build networks and how we interconnect devices to each other. However, we need to consider that even small networks can be very complex. Network topology and layout affects the scalability and the security, and wireless networks also have a topology. The first one we look at is a bus. This is a LAN with a central cable to which all nodes connect. Each device handles its own communication control. A bus is a low cost and widely used in the start of the PC era. For example, we had thick and thin Ethernet, as well as AppleTalk. Advantages include things like it's scalable and permits node failure. The disadvantages, a bus failure. A tree is a devices that are connected to a branch on the network. It is generally generalized bus topology. We have a tree root, which is the head end. A cable starts at the head end, each which may have many branches. Branches may have additional branches, which can form a complex structure. The advantages here, it's scalable, it permits a node failure. The disadvantages here, possible split of the network due to some failures. Ring is a closed loop topology. A ring topology has all the network nodes connected by a unidirectional transmission link to form a closed loop. Now, FDDI and token ring use this topology. The advantages, it is deterministic, which means it is possible to calculate the maximum time that will pass before the end station will be capable of transmitting. Disadvantages, it is a single point of failure. A mesh where all nodes are connected to each other, and as you can see, the number of connection is n, which is the number of nodes times n minus 1 over 2. Adding another one, as you can see, the complexity increases quite drastically. The advantages here is definitely redundancy. However, the disadvantages is expensive, it's complex, and the scalability is also an issue. We'll use this normally in a cluster environment or where a failover requirement such as a web farm for a front end. A star topology, which means that all of the nodes are connected to a central device. The nodes are connected in a single host. All communication passes through this host, which is usually a large mainframe or a network hub. The advantages here is that it permits node or cable failure. It is very scalable. Disadvantages, we have a single point of failure. Now, a security perimeter is the first line of defense between a trusted and untrusted network. There should be no direct physical connection between trusted and untrusted networks. A security perimeter, most widely used as the implementation of network partitioning. Then also, when we look at the physical layer, the technology and the implementation can be the physical networks, which can have cabling technologies and components. Now, wireless networks use frequency ranges and also encryption and authentication on those. When we look at cables, we need to select cables based on our requirements such as throughput, distance between devices, data sensitivity, and possibly the environment. The most common cable that we use these days is the twisted pair. It's the simplest and cheapest cabling. We've got unshielded and also shielded twisted pair, and as you can see from those images, the top one is unshielded, bottom one shielded. The advantages, it's thin and cheap. On the shielded one, magnetic frequency, you can actually have radiation, sort of like emission that can be shielded, so we don't have any interference from the outside or from the inside to the outside. Disadvantages, some EFM issues can be an issue around this if it's not shielded. However, there can be signaling delays or skew in video applications, and sometimes you saw this on a TV screen or a monitor, such as ghosting effect. Now, here are the 6 levels of the unshielded and shielded twisted pair. We've got category 1, which is analog and digital voice. Category 2, ISDN and medium speed up to 4 megabits. Category 3, we have high-speed data and LAN traffic up to 10 megabits. Category 4, LAN traffic up to 60 megabits, and this was usually in the tokenary environment. Category 5, your 100 megabit unshielded twisted pair LAN technologies. We have 5E, which is an enhanced performance spec for Cat 5. And then Category 6, which is gigabit Ethernet or 1000 megabits per second. And possibly now as well, we've seen some 10 gigabit being pushed through some of these shorter distances. Here's a table that you can actually look at the categories, the transmission rates, and then also the use. Go through this and just actually make sure you actually understand and see where it is utilized. Then in the older technologies, we had coaxial cable, RG58. The conducting wire is thicker than twisted pair. It provides a very good combination of high bandwidth and excellent noise immunity, but it's more expensive. There are 2 transmission methods, which are baseband and broadband, where baseband carries only one single channel and broadband carries multiple channels such as video, voice, and data. Expensive and physically stiff. Fiber optics have 3 components. We have a light source, optical fiber cable, multi-mode and single mode, and we also have a light detector. The advantages include fiber optic cable carries signals as light waves, creating higher transmission speeds and greater distances. It is very cheap to tap and is the most resistant to interference. It's usually reserved for connections between the backbone and devices in a large network. Disadvantages, difficult to manage and splice, and it is expensive. Another table here, we can actually look at the media type, such as thicknet coax, the maximum distance you can have with this, the bandwidth, and some advantages and disadvantages. Now, as you can see, thicknet and thinnet. Thicknet has a 500 meter, thinnet 185 meters. Shielded twisted pair 100 meters, or otherwise known as 300 feet. Cat 3 and Cat 5. And then you have fiber, which can multi-mode or single mode, which can run up to 2 kilometers for multi-mode. And we have seen some much larger kilometers in the single mode, such as 20 kilometers. Microwaves are electronic magnetic waves, frequencies from 300 megahertz to 300 gigahertz. It's in the ultra high frequency, super high frequency, and extremely high frequency ranges from 1 millimeter to 1 meter wavelengths. It is usually used for wide area communications such as SATCOM, TV broadcast, the metropolitan area communications such as IEEE 802.16, which is WiMAX cellular communication. And then also in that frequency range, we do have local area communications such as IEEE 802.11a, b, and g, and then PAN as well in the Bluetooth area. It requires a line of sight for some technologies. You may have a single relay over long distances, such as land, sea, and space. And you do have operating constraints, such as ice, snow, heavy rain, dust storms, solar flares, electromagnetic interference, and also high altitude electromagnetic pulse. This may affect the communication negatively. Now, this concludes part 1. Let's go through that. And next one we're going to look at is the spectrum in part 2.